Welcome back to The Good Oil. We're back with Ryan Anthony from the University of Wollongong, and today we're tackling the question that comes up consistently, especially as more people shift towards a plant-based eating diet. Does it matter where your omega-3 comes from, fish or algae? Is there an actual difference? Ryan, great to have you back. Ryan, welcome back.
Thank you for having me.
Let's start with the basics. Plenty of plants contain omega-3, including flaxseed, chia seeds, walnuts, and etc. Why can't someone just eat those and tick the box with omega-3?
Yeah, the biggest problem with that is, and you're right, they are technically omega-3s, but we have some differences between shorter chain omega-3s, longer chain, very long chain. The stuff that we really want is EPA and DHA. All of the items you just mentioned contain something called alpha-linolenic acid, which is one of the shorter chain omega-3s. Problem with that is our body is really bad at converting that. We don't do a good job of going from the ALA, for example, the alpha-linolenic acid, to EPA and DHA in humans.
So when we talk about how it's inefficient, the conversion of ALA to DHA, EPA, how inefficient are we talking about?
I think you'd be generous if you said it was about 1%. When we've actually looked in humans, that conversion is almost non-existent. It's really not worth talking about in human evidence. In animal models, it's a bit different, but in humans, it's really low.
Yeah. And did you see evidence of the deficiencies in athletes who you studied were following plant-based diets?
Yeah, we have seen this across the research, including in my own study. It's one of the examples where we think there is actually some conversion, because obviously vegans still have EPA and DHA in their red blood cells, but they don't really eat any preformed EPA or DHA. So we think that's where you might get an uptick in conversion from ALA to EPA and DHA. But in terms of population level stuff, we generally see about 1% to 1.5% lower in vegans compared to those that just have omnivore diets.
Okay, in terms of the omega-3 index.
Yep.
Okay. What sort of levels were they at?
In my study, they were about 4%.
Okay, so that's very low.
Yeah.
Okay. So where does algae fit in this story, right? I'm a vegetarian. I have algae, DHA. Why is algae actually a marine source of DHA, EPA rather than a plant source?
Yeah, it's actually a really interesting conversation point. Firstly, it's not a plant-based source. It seems to be a bit misconception.
Yeah.
It's suitable for plant-based eaters, but it's actually a single-cell organism that is marine-derived.
Yeah.
Now, it itself can produce EPA and DHA. So algae contains the EPA and DHA that the fish actually eat. So the reason fish have so much EPA and DHA is because in the marine ecosystem, they eat the algae. So the smaller fish eat the algae, the bigger fish eat the smaller fish, et cetera, et cetera.
Yeah. And that's why I'm assuming that's why you see the profile of EPA, DHA change in the different types of fish.
Yep.
Okay. Well, let's delve into the fish versus algae, debate. Walk us through the pilot study that you did. Who were the participants and what exactly did you compare?
Yep. So this was when we first introduced this microencapsulated powder and compressed it into a tablet. We took in highly endurance trained athletes and we compared fish versus algae with very, very similar DHA levels. So they were both about 600 milligrams in terms of the dose that we gave them, and we gave it to them for 12 weeks.
And then with these endurance athletes, doing training 10 hours or more per week, there's a concern in literature that very high training volumes can actually reduce the omega-3 index. Did you see that evidence, and why would that be so?
I personally can't attest to that. Our baseline sample, they represented the population. So we had a mix of vegan as well as omnivore athletes. The vegans seemed to line up pretty well with general population vegan athletes, and the omnivores lined up pretty well with general population omnivores. I think the vegans were somewhere around 4%, and the omnivores were just low 5, so 5.2, 5.3. And that's roughly where the Australian population sits. So in terms of differences there wasn't really anything to talk about. There is a group of researchers that seem to think that endurance training or protracted periods of training can do something to the levels of EPA and DHA. I'm not really sold on that. I think the hypothesis is that that it's such a high demand that those molecules in phospholipid membranes are being liberated as either an energy source or something like that.
Yeah.
We haven't seen that consistently in the research at all.
Yeah, and I know we talked about this in the previous episode with regards in this study you use the chewable tablets, which we talked about, rather than traditional sort of capsules using oils. Touch on a bit more about why that format, and I'm really keen to understand how the participants found it, and which really relates to anyone here that wants to formulate DHA or a supplement for for athletes. Why this is a better option and in terms of the compliance and so forth.
It was very unique. Like we mentioned in the previous episode, telling someone to chew fish oil, it just sounds horrendous.
Yeah.
But the end product was unreal. And having that microencapsulation to be able to do basically whatever we wanted with it. Put it into a bar, you could put it into tablets. We chose tablets and blister packed them. And the participants, for the most part, loved them. Like I can attest to myself, when they first came in and we were testing them, I was very apprehensive to chew one.
Yeah. And
then had it and I was hooked. I was like, this is what I want to actually be doing. I'm not a fan of swallowing capsules.
Yeah.
So having that option to put it into food products, it also really reinforces that food first approach. It's not just swallowing capsules. You can actually put it into a powder, put it into yogurt, and all of a sudden now you've got protein plus omega-3s.
Yeah, and it sort of actually is aligned with what's happening at the moment in markets like the US, where people are sort of capsule fatigued.
Yep.
So, and that's why we're seeing the growth of chewable tablets and even things like, stick packs where you just open and put in your mouth and over, like you said, in yogurt and so forth. Some of the participants experienced some mild gastrointestinal discomfort early on. Was that caused by that or how significant was it?
I think part of it in the pilot study was we were still trying to figure out how do we get a high enough oil load or dose into those tablets without it tasting fishy.
Yeah.
And because we used a reasonably low concentration, the rest of it was fillers. So basically sugar, alcohol, sorbitol, those sorts of things.
Yeah, yeah.
They did have to take quite a few of the tablets in that first study. And as a result of that, I think the dose of those sugar alcohols were on the level of potentially causing some issues.
Yeah.
So it was more how we approached it in terms of trying to get that balance.
Yeah.
But it was quite low and it was generally pretty minor.
Okay. So let's talk about after 12 weeks, and what the results look like for both groups, especially in terms of their omega-3 index. Did they rise?
Both groups did, yes.
Okay.
And basically exact same between the groups. So we had about a 1.6 to 1.7% increase in the omega-3 index.
Yeah.
And there was a lot of learnings from that study, which we took into future studies.
Yeah.
So compliance was generally good, but really trying to drive that home. But in our key outcomes, we really didn't see any difference between the two, which was quite promising for us because we'd kind of hung our hats on that.
Yeah. But so you didn't see any difference between the fish group and the algae group?
No.
The omega-3 was pretty much the same?
Yep.
So for a vegan athlete then who has been told they need fish to get proper omega-3, and there are a lot of plant-based or vegan athletes, what does this finding mean to them?
That there is a very viable alternative in a sustainable source of algae that gives you equivalent DHA. Like the molecule itself is the molecule. You get that source of DHA and you don't have to get it from a fish source.
Yeah, yeah. And then in the actual fish group, EPA went up slightly, which makes sense given that the composition of fish oil. But DHA results were essentially identical between the groups. Why is DHA more important driver here?
It's really what elevated our omega-3 index. So for us, it drove that 1.7% change.
Yeah,
the EPA contributed to a small amount, as you said, in the fish group, because there was a small amount of EPA in the oil. Yeah. But overall, it was really DHA driving that omega-3 index.
Excellent. And then with your larger companion paper in terms of the performance nutrition, also compared fish and algae-derived DHA in a broader group in trained adults.
Yep.
Did those findings confirm what you saw in the pilot?
It did.
Yeah.
So as I said, we had quite a few learnings from that pilot study, which we brought into that future paper. The one was that we wanted to try and get at least a 2% increase in the omega-3 index.
Yeah.
So there was dose adjustments. We went from about 600-ish milligrams in the pilot to 715 in the performance nutrition paper. But in terms of comparisons between the fish and algae, it was the exact same story. Both groups increased at the exact same amount.
Okay. And so just going on the DHA change and how, you look. So your performance nutrition paper also looked at body composition, including whether DHA changed from fat mass or lean mass from that perspective. This is something that a lot of athletes are interested in, right? What did you find?
Unfortunately, it's not the selling point of the paper.
Yeah.
There was no difference in body composition, no meaningful difference. We saw an overall effect for lean mass, which both groups increased. So when I say both, in this group, we had fish, algae, and control. There was no differences between the groups, and all three groups slightly increased their lean mass.
Mm-hmm.
They're trained adults, their ongoing training, we would expect over 12 weeks that they're still making improvements. Nothing occurred between groups. So there was no differences between lean mass between the groups. There was no differences in fat mass between the groups. So in terms of the body recomposition effects of omega-3, at least in our study, they just weren't there.
Yeah. But some earlier studies suggested omega-3 might increase lean mass or reduce fat. Why might your results, differ here?
I think one of the ways is how we actually measured lean body mass. We used DEXA-derived lean mass metrics. There's a difference there with bioelectrical impedance, or BIA, like the gym scales that you go to where you stand on and maybe hold handles and it sends a current through your body. Using DEXA, there are still limitations with it in that lean mass is not the same as muscle mass. So muscle mass will be mostly the contractile stuff around your body. So you think about your biceps. Lean mass includes a lot more than just that. It includes liquid, fluid, your organs, for example. And when you're not tightly controlling how that body composition assessment occurs, if you have an extra glass of water before you get on a DEXA machine, or you're slightly more hydrated on that day, all of a sudden lean mass goes up. So we actually used a metric called appendicular lean mass, where it basically on the DEXA machine, because it images you can cut off the arms and the legs. When I say cut off, we image it. And then have a look at where there's no real organs other than muscle tissue in your arms, your legs. And in that, it was within 2 decimal points in terms of week 0 to week 12. There was absolutely no difference.
So the bottom line in this, a dietary achievable dose of DHA will meaningfully improve your omega-3 index, which we've discussed. But it's not a body recomposition tool on its own, right? Is that a fair summary?
Yep.
And how would you, relay that to our listeners in terms of, where that DHA plays in the dietary, regime?
We don't really have good mechanistic evidence for why it would start all of a sudden dropping fat mass or increasing lean mass, at least in trained and healthy adults. We have seen some stuff in populations where they're at risk of losing muscle mass. It doesn't increase it, but it prevents how quickly it goes away. But in healthy adults, especially physically trained, we haven't really seen that it's going to do anything for fat mass or lean mass. In terms of dosing, it was the same dose that we've sort of translated through the decades of research, right around that 2 to 3 fatty fish meals a week, or about 600 to 800 milligrams of DHA.
I just wanted to ask you, right at the moment, especially in the US and China, the use of GLP-1 is fast growing. By users to be basically being used to reduce weight. The outcome of that is obviously losing appetite, but also losing muscle mass. Where do you see DHA playing a role in trying to curb that muscle loss going forward? Do you think there's enough evidence there, or do you think there's certainly opportunity for studies to happen?
I'll preface this by saying this is not my area of expertise. And that we have no direct comparison studies with omega-3 plus GLPs versus non, at least that I'm aware of. There's none that exist. But from a mechanistic perspective, it's definitely plausible. Because where we have seen changes in lean mass, as I just mentioned, is where there's groups that are at risk of losing lean mass. A researcher from, I'm going to get this wrong, and he's probably not going to be happy about this, but he's either Canada or the US, Chris McGlory. I'm pretty sure he's US. He's had a look at limb immobilization. So they basically have people come into the lab, supplement them with omega-3s, and then immobilize a limb and look at how much that lean tissue gets reduced while that limb is immobilized. He did a study, I want to say maybe 5-6 years ago, where he did exactly that and found that the omega-3 group retained more of the lean mass in the leg that wasn't doing anything. And what's quite interesting with the GLP-1 story is where we think lean mass is actually getting reduced is primarily down to that you're eating a lot less. So that ability to reduce your appetite, you basically put yourself into a severe caloric deficit. By doing that, you put, like, muscle is energetically expensive for our body. It costs a lot to keep it. So when we're in basically a starvation mode, as our body sees it, it's going to pull on that muscle and say, good to go, we'll send you out the door because we need energy. You're costing us too much to keep around. And that's where we think if omega-3s are doing something, it's probably in that preservation aspect. So long story short, I think it's definitely plausible mechanistically. We don't have data on it yet, and I would love to run a study on that if anyone would like to fund it.
Yeah, that'd be great. I mean, look, it's a phenomenon that's happening, and with right now, I think it's about 16% of the population in the US that's actually using it or have used it. And it's completely reshaping the way food retail is being sold to the consumers. Right, it's more dense, nutrient rich, and so forth. I want to move on to practical guidance. I know that you've got a bit of you're an athlete yourself, or you do a lot of training yourself. But let's make this practical for our listeners. If someone's training regularly, whether they're a runner, a cyclist, gym goer, should they be taking an omega-3 supplement based on your studies? And if so, what and how much?
I'm obviously biased on this. I've been doing this for a long time.
Yeah.
But it's not just what our study has found. If you put our study in the broader context of the literature, it all seems to point towards improved recovery, improved benefit to athletes. So the answer would be yes, I think you should be taking one. What's important is actually checking if you are low in omega-3s by doing a finger prick blood test or something like that, and then modulating your dose based on that. So if let's say you're a vegan athlete and you're at the lower end of that scale, you might need more than, let's say, an omnivore athlete who has a couple of tins of tuna per week. So trying to get that balance to get us in the sweet spot of where we need to be without feeling like you're swallowing 10 capsules a day.
Yeah. Well, for the listeners, we'll actually tag in a website where they can get an omega-3 index kit as well. What about for someone who is either vegan or vegetarian or flexitarian, which is a growing segment? Is algal omega-3 generally equivalent, or there any reason to prefer fish-derived over algae?
The main challenge at the moment is what's available in the market. If you go down to any chemist at the moment, the algal options are quite limited. If you look for vegan-based omega-3, it's those plant-based sources. You're going to see a lot of ALA. The more that algae starts making its way into markets and that price starts coming down and it becomes more accessible, I think that's going to be quite helpful for most people. Me personally, I look for a DHA dominant fish oil capsule when I go to the shops to buy my fish oil. It's very, very limited in terms of what's actually available out there for DHA. And I think algae can really solve that because it tends to be higher in DHA.
Yeah.
So keep an eye on what those labels are actually reading. And try get a high dose per capsule so that you're not having to take 10 of these capsules.
Yeah. So we talked about you providing your subjects, or participants, omega-3, the chewable tablets. For anyone that sort of wants to start getting into and taking the supplementation of omega-3s, especially DHA, how long until they can actually see a difference in their omega-3 index?
Yeah. It is very dose dependent. We try not to look at it as let's get to a number, because as soon as you do that and you hit the goal, then all of a sudden you stop doing whatever you were doing. For us, 700 to 800 milligrams of DHA is going to get you 99% of the theoretical benefit.
Yeah.
But it's important that you do that long term, and it is really a lifelong change. It's not get yourself to a number and then just job done. You can, in theory, go higher. So let's say up to 1,200 to 1,500 milligrams of DHA per day, it will get you there quicker. So in terms of our dose that we've used, you're looking at about 8 weeks to really get to that number. The higher the dose, the quicker you'll get there. but it's not necessary to maintain that dose. So let's say you're on, say, 2,000 milligrams of DHA. You'll probably get there in 4 weeks, but you don't need to maintain that 2,000 milligrams for forever. So it's dose and time dependent.
And I suppose you mentioned before that in the case of Australia, the average is between 4 and 5% when we talk about the Omega-3 index. Can someone realistically reach the 8% target over a certain period of time?
Yeah, absolutely. The guidelines are actually surprisingly good for this. Like when we look at the heart-specific recommendations of 2 to 3 fatty fish meals, that's right in range of 600 to 800 milligrams of DHA.
Yeah.
So a couple of capsules a day or 2 to 3 fatty fish meals per week and you're done.
Yeah, good. Okay, so let's looking ahead, and as we sort of getting closer to wrapping up. So you've now published quite a few papers from your research program. What's the next question that you want to answer? Because I think that's what people are looking at, like the next horizon. And you look at DHA, it's the most researched, supplement, over 50,000 papers. But for you personally, what would be the next thing?
I think this goes all the way back to our study design issues, where one of the other issues with the current crop of evidence is EPA and DHA aren't differentiated. When you think fish oil or omega-3, it's just EPA plus DHA. I would love to start seeing, and it's now possible with algae-based products, let's actually compare the differences between EPA and DHA. So let's separate these two out into different groups. Let's look at, does EPA do the job in, let's say, soreness? Is it DHA that does it? I think that's the next frontier in terms of like trying to figure out mechanisms. And then a step from that would be in terms of the muscle recovery space, which I think we touched on earlier. Those resolvins are really hard to measure in humans. There's been attempts and it's been done in very limited groups. I would love to see that become widely available so that we can actually get this mechanism out there and see what's happening.
Yeah. And I mean, you talk about particular groups, but what particular groups is there, or is there a particular group that you think is underserved when it comes to, omega-3 or DHA levels in their blood?
I don't want to say athletes are underserved because they've got a lot of resources, but in the athlete arena, we see much less resourcing in female athletes. We've noticed this when we go out to sporting teams and we try to work with their sports dietitians at a critical time when, especially when you look at the pre-pregnancy era of female athletes that are in their 20s usually, and they're potentially on the horizon of having children not long after their career. They're some of the lowest omega-3 index values that we've seen. And that pre-pregnancy era is critical. We know for preterm births, all those sorts of things. I think that group could use a bit more attention with the omega-3 space and really trying to focus in on getting those values up. Excellent.
And so last question, this is your chance. We have a lot of listeners who are either coaches, sports dietitians and, athletes listening. What would be the one message that you'd like to land with them in terms of the supplementation of DHA, EPA?
Yeah. Go for the low-hanging fruit first. Low dose, 1 to 2 capsules as often as you can long term. We do see benefit across multiple organ systems. So heart, brain, muscle. Obviously, we focused in on mostly the muscle inflammatory side of things. But just start, because anything above 0 is good. And then try to work that into a regular routine.
Excellent. Well, Ryan, that was very insightful. I really enjoyed that session. Thank you so much for your time and really appreciate it.
My pleasure. Thank you.
Ryan, 2 fantastic episodes. The science is clear. Most people, including athletes, have a suboptimal omega-3 index. A modest, consistent dose of DHA from fish or algae taken over at least 8 weeks makes a real difference in omega-3 status, muscle soreness and recovery. And if you're plant-based, algae is generally equivalent. The fish don't need to be the middleman.
DHA, the athlete's choice. Heart and brain, let's raise our voice. Muscle recovery will go far. With Omega-3, your shining star.